Hi guys, welcome back. We are continuing our conversation with triple integrals, and then the example that you see in front of you here is to set up the integral to find the volume of the region in the first octant, bounded above by the cylinder z equals 1 minus y squared, and lying between the vertical planes of x plus y equals 1 and x plus y is equal to 3. They've actually were nice enough to give us the picture for what's going on here. So as you guys can see, we see the cylinder. You can see that it is actually in the first octant. And then the other interesting point I want to make here is the fact that they've given you the equations, but they've set them up in terms of x. And we're going to talk about that in a second about why that's suggested. So the first thing that I want to do is I want to actually look at the plane that's right here, the bottom plane. So I'm going to go ahead and draw myself an xy coordinate system, and we're going to kind of see what is going on with that. So first of all, I'm going to go ahead and label my axis as y and x. And I know that the equations are in terms of x, but just for me to graph them very easily, we are just going to get them in terms of y, just because we're conditioned to graph y equals negative x plus 3. So we can see that at the y-intercept is 3, the x-intercept is also going to be 3, and we have a slope of negative 1, right? So there we go with that. Then we look at the equation for y equals negative x plus 1. Again, we will have a y-intercept at 1 and an x-intercept also at 1, and draw ourselves a region like so. And then the other thing that we want to look at here is, because we really haven't bounded it too much, but the other thing we want to look at is the fact that, well, what's happening since we're looking at this plane xy, well, what happens when z is equal to 0, right? So when z is equal to 0, we get 1 minus y squared is equal to 0. Therefore, y is going to be equal to positive and negative 1. So we also want to look at the fact that y is equal to 1. And then we want to look at, since it's in the first octant, right, we are just looking at this region right here. So that's actually really important for us when we start setting up this triple integral. All right. So next, the thing we're going to do is we're going to look at the functions themselves. So when I set up my triple integral, remember I want it in terms of x, y, and z. So the first part we want to do is look at our function in terms of x, y, and z. And so I'm noticing that I've got the equation that z is equal to 1 minus y squared, right? So that's the top part of this region in terms of z. And the bottom part of this region is actually where z is equal to 0, right? Because we're looking at these planes of x plus y equals 1 and y plus 1 is equal to 3. So the first suggestion is to go ahead, since we have z equations, we actually know the top and the bottom curves, we can just go ahead and say that our curves with respect to z is going to be, the bottom curve is z equals 0, because remember these are the x equals equations, and then our top curve is going to be 1 minus y squared. So why did they suggest that we do x equals? So then remembering that when you're setting up the other two, you kind of want to look at what we call the trace, right? So we want to look at the two-dimensional space, the two-dimensional space of the variables that we still have to do. And so since it's looking like we have a y here, right? Well, let's go ahead and keep it going and do in terms of x. Let's go ahead and have the y values here, and then the y coordinates will be here. So what we're going to end up doing here is we're going to say, well, this is actually equal to, x is equal to 3 minus y. And so that's going to be our right-hand curve. So remember that when we're doing right minus left, we always go right. And then the left-hand curve, which is going to be x equals 1 minus y, that's going to be our bottom curve. Right? So remember, whenever we're going to go in terms of x equals, it's always right minus left. And then what we can then finish doing is, okay, well now, since everything now is in terms of y, well, remember our last coordinate system is going to be in terms of a constant. And so we just have to look at, well, what are our y values in the shaded region? Well, the lower y value that we have here is actually y equals 0. Oh, and by the way, just so we know, so these are going to be the equations of x is equal to, and then the next one we're looking at is y is equal to. And so remember, this last integral is always going to be values. These can be curves, and these are surfaces. This is usually, or that's usually what we do for these other two things. And then the highest y value in our region here is simply going to be 1. All right. So remembering that the first part of our integral is always going to be equations of surfaces, and then you use what we call our traces, or a two-dimensional version of what the xy plane looks like to give us our functions for this and our coordinates for this. Okay, so I'm going to go ahead and stop our video here for this problem. This is all we need to do is set this problem up. We got 2 more examples we're going to do. So hopefully this makes sense, and I will see you guys in that next video. So take care.